Yes, yes, yes,
Ha,
madam.
okay. Okay, fine. So now students, please pay attention, okay? So we'll go to our start box. We'll go to WEKA, okay? And the version which is downloaded is 3.9.4. Okay, there are various versions which are available on the website. However, the link which I gave you in the mail, that will download this 3.9.4, which will take you towards that, and of course that's the latest one. But in case if you have downloaded any other version, that's not a problem at all. Okay, it will still work very fine. Okay? So nothing to worry about that. Okay, now if you people are working with me also, that is fine. Okay, however, I won't be able to see the chat box over here. I'm just trying to figure out if I can see that. Just give me a second. Uh, because I can't see the chat box. So, anyways, I'll twiddle it over here and just check out. Okay. So, let us start with this. Okay. The first and the foremost thing is I'll show you the data sheet first. Okay. Now, the data sheet for your skills and competency exam, I have sent it to you all on the mail. Okay, for IT students and computer students and ENTC students who are in my class, for those students, the data set as well as the report is already been uploaded on the Google Classroom. Okay, so for them we have not sent it separately. However, for mechanical students, for civil students and ENTC students who are in Pradna ma'am's batch, okay, for them I had sent the data sheet as well as the report on the mail yesterday itself. Okay, so kindly refer to those mail, that particular mail, and see the data as well as the group of students. Also I have mentioned in that Excel sheet itself that which are the students who are going to work on which particular data set. Okay, so I think that we have already done. Okay, now let us go to we will just have a little recap of that also. Just give me 1 minute. Yeah, so we'll have a recap also. I have already told this to you people in the session, but still a little more recap about it. Okay. Now this is the data sheet. Okay. Now the one which has come in the mail, it's the same data sheet, only I have separated it out. For mechanical, I've made a separate Excel sheet, for civil separate, and for ENTC separate. That's it. Nothing else. Okay. So this is the data sheet which is available to you people. Okay, and so mechanical there are 3 groups and civil there are 2 groups. Mechanical, for example, this particular data of temperature, exhaust vacuum, ambient pressure, relative humidity, these are going to be the input parameters, and the output parameter is going to be the net hourly electrical energy output in megawatts. Now these are the students who are going to work on this particular data sheet. Okay, then the second sheet, this is the second sheet. The input parameters remain the same, the output parameter remains the same, however the values are different. Okay, so please make a note of this, and these are the students who are going to work in for this particular data with this particular data sheet. And the same goes with uh, mechanical third group, and these are the students who are going to work with this. The same input parameters, the same output parameter, however the data is going to be different. Okay, the next comes civil. Now this is the first group. This is the input parameters are cement, blast furnace slag, water, superplasticizer, coarse, fine aggregate per kg per meter cube, and the age. Okay, and the output parameter is going to be 28 day strength in MPa. Okay, so and these are the group of students who are going to work on this data set. In a similar fashion, for the second group also, uh, you have the same data, the same input parameters and the same output parameter. However, the data is different. Okay? And these are the group of students who are going to work on this data sheet. Now, when it comes to ENTC, it is different. You are going to work with time series data. Okay, so yesterday, not yesterday, during our session, I explained you how you will actually work with that particular data, and we are going to deal with it in little more detail in the next week as well. Okay, so just check out here. This is the January data. This is monthly mean temperature. So ENTC people, I'm repeating this again. ENTC people are going to work with time series data. Okay. So this is monthly mean temperature. And this is the January data, which this group of people will work on. This group of people from 21 to 37 will work on February, and 39 to 68 will work with March. Okay, so this data sheet is already there with you. Okay. So now we will start with the implementation phase in WEKA. Now for today's demonstration, I have made my own data set ready for this. In the similar fashion you can do for your own data. Okay, so let me show you that data first. Okay. So, okay, now just check out here. First and the foremost thing is that we are all aware that the data set should be divided into basically three parts. The first thing is 70% of training. 70% of the data will go for training. 15% will go for test validation, and the next 15% will go for testing. Okay, this is the data division which usually it is being used. However, in this data set which we have given it to you, the data set is nearly around 100 to 120 only. So you can increase the training size maybe by from 70, you can make it 75% or max by 80, but don't go beyond 80. Okay, 80 also if required you can go, but till 75 I think it is fine. Okay, you can stretch it till 75. Okay, so for this what we have to do is, first of all you have to make your own Excel sheet. Okay, and divide the data into training and testing. Okay, now in this case your training data will consist of, you have to make two files, Excel files. The first Excel file will be called as training, which will consist of your training as well as the validation data. Okay, the bifurcation we will do it in the software. Okay, I hope you people have understood this. Make a single Excel sheet, and in that Excel sheet for training, only for training data, include the training data as well as the validation data. Okay, now for this demonstration I have made this data ready, which is a concrete data. So I will not go into what are the inputs and what are the output. Okay, now see here, I have 9 input parameters: C, NFA, RFA, NC20, NC10, RC20, RC10, A, that is admixture, water cement ratio, and S, that is the strength of concrete, that is my output parameter. So I have 9 input parameters and this is my output parameter. Okay. Now this data, as I said some time back, that this is a data which is for training as well as validation. Okay. Now this is Excel sheet data. For WEKA, we require it in CSV format. Okay. So comma delimited. So what you have to do is, it's very simple. Just go to file, just go to save as. Okay. And wherever you want, you can save that. Okay. Only the thing is, instead of save as type Excel workbook, you can just click over here and you can save as CSV, as you can see here. Okay, so CSV into bracket MS DOS. Okay, or you can go CSV comma delimited. This will be more better. Okay, so comma delimited. So you have to save it in this format. Okay, That is mandatory, or else it won't take it. Okay. Now in this similar fashion, you also have to make the testing data ready. Okay. So always be very careful that when you make this data sheet ready in CSV format, the headings of course should be there, and it should be same. Okay, म्हणजे थोडं सुद्धा इकडे तिकडे नको, or else the WEKA will not recognize your data sheet. Okay, then be careful with your cells also in this sheet, any sheet of course, because if any sheet, if it is empty, or if there is some text file or text over there, then in that case WEKA is not going to consider that. Okay, so be very careful. No empty, no text. Okay, should be there. So this is done. So I have made two sheets ready here. One is training, the next is testing. Okay, so I hope this is clear to you. And if you can see here, I'll show you everything. Just check out here. Yes, if you can see this, it is Microsoft Excel comma separated value files. Okay, values file. It means it is saved in CSV format. Okay, so now let me close this. Okay. And let me go to WEKA now. Okay. Now this is what you will see when you open it. I'll again open it for you people. Okay, you can go to your main start. Here you can just write WEKA, and you will have WEKA 3.9.4. You can just open that. Okay, once you open it, okay, you'll get this particular window. Okay, now just follow the steps as I show it to you. Okay, go to Explorer. Okay, now once you go to the Explorer, this is disturbing me. Let it be. Okay, let us go to Explorer, go to Open File. Okay, and here you can open your sheet. Okay. Now you have to first open your training sheet. Okay. Now go to the file, look into the folder where you have saved your file. So I have saved my file in E drive, in college, in semester 2, in teaching, and yes, here is my file. However, I'm not able to see the file here, because if you see here, it is asking me the files of type. Okay, now this is one more property of WEKA, that files also can be saved in ARFF format as well. Okay, now this is the format which you can see mostly, which has been cited in the website, WEKA website. Okay, so if you want, you can do it in this particular format also, but if you ask me, then CSV becomes easy for us, and we have been working on this CSV format for quite a long time, and so it becomes easy, so we use CSV. Okay? It is up to you whether you want to use ARFF or CSV. So now once I identify my files here, go to training. Okay, because I am going to insert my training data first, and just say open. Now here you can see that all my 9 parameters and my 10th parameter, that is strength, is listed over here. Okay, I'm just going to check this by saying all. Okay, now what you can see here is on the other side, that each parameter which you click over here, okay, its data or its characteristics can be seen over here. So what is the minimum, what is the maximum, what is the mean, what is standard deviation, okay, and the histogram, okay, of the pattern of data which is available for that particular parameter. It also can be seen over here. Just view it over here. Okay, so it's as good as this. Okay, now this analysis at the initial phase is also very important when you work with any type of data. Okay, so now just check out here for the strength. There's quite a pattern of data over here. Okay, So now let us go to the next part. The next part is go to classify. Okay, the very much sorry, the next tab, go to choose. Okay, now when I go to choose, go to functions. I hope it is visible to all. Okay, go to functions, and here you can see under the name of multi-layer perceptron. Okay, if you try to search it under the name of say artificial neural network, you won't get it like that. Okay, it is under the name of multi-layer perceptron. Okay, so just click this multi-layer perceptron, and here this will get checked at the choose tab box, as you can see over here. Okay, so now next, first choose your training set. Okay, now what we will do is we will do some changes over here. Okay, so are you people with me right now? Somebody please let
Yes,
me
madam.
know.
Yes,
Yeah,
yes, madam. Yes.
ma'am, you can just keep a watch on the chat box also. There are 4 chats over there. uh, Ma'am, please share the recording and lecture so that we can. Okay, let me finish the lecture first, then I can do that. I'll do that surely. Yes, yes, yes. Okay, so ma'am, please record of this lecture. Yes, dear, I'll do that. Let me finish this session first, then I will surely do that. Okay. So now, going ahead, I'll go to this particular part. Now, what I'm going to do is I'm just going to click on this particular tab. Okay, now once I click on this particular tab, okay, I'll get this particular data. Now I'll fill this data one by one. Okay, and I'll show you some few things as well. Now this is graphical user interface, GUI. Okay, let me not uh, click this right now. I'll show it to you a bit later. Okay, then auto build, yes, we want it to auto build. If you want to build it yourself, you can do that by saying false. Okay, then batch size, if you're doing batch training. Okay, then debug, yes, not required. DK is also not required. Capabilities, do not check it. Okay, now the most important is hidden layers. Now, what is a property of WEKA is that by default, it is going to consider the hidden layer as 0. So you can see the letter A over there. I'm talking about hidden layers. Okay. Now, if you want a single hidden layer, say for example, okay, and you want say 5 neurons or 2 neurons in the hidden layer. Okay. I'll just write here 2. Okay, now what is this particular number telling me under this tab of hidden layers? It is saying that there is a single hidden layer, okay, with 2 neurons in the hidden layer. Okay, if I want to increase the hidden layers, okay, you can write it as say comma and say write it as say 7. Then it means that this particular network, the architecture of the network will be input parameter, output parameter, 9 in this particular case, 1 is my output. And there are 2 hidden layers with 2 number of hidden neurons in the first hidden layer and 7 number of neurons in the second hidden layer. That is what is the meaning of this. So depending upon the number of hidden layers and the hidden neurons, you can change this. Okay, say comma and you can write it. However, I'll keep it as 2 for time being for our understanding. Okay, so that we can analyze that particular data. Okay. Yeah, going next, you know what is learning rate, you know what is momentum rate. This also can be changed if you want. Okay, this is also one of the factor which you can change and you can check the performance of your model. Okay, now you don't require nominal to binary filter, none of you. So I mean we require, so let us make it as true. You want to normalize the attributes by default. In fact, that is one of the limitation of WEKA, that it will normalize the data between -1 to 1. Okay, no other normalization can be done in the inbuilt system right now. Okay, if you want to do that, then you'll have to write a code in Java. Okay, and which can be attached over here. Okay, for right now we are not going to do that. So The normalization, yes, you want to do that, so write it as true. Okay, and the normalization can be between will be between -1 to 1. Okay, normalized numeric class, yes. Okay, and decimal places, how much ever you want, 2 3 for the prediction. Okay, reset, yes, you want to reset is after every change if you do it. Okay, and resume, let's make it as false. The reason, I'll show it to you. The seed, now this is seed is actually to initialize the random number. If you want to randomize your weights, okay, then you can use this particular property. Okay, then the training time, now this training time is nothing but the number of epochs. I hope you know what is epochs. Epochs is nothing but the iterations, what popularly it is being called as. So you can change it over here if you want 500, 600, or we can change it in GUI also later. But at the time being, let's keep it as 500. Okay. Then the next comes here is the validation set size. Okay. Now, if you people remember when I told you about the Excel sheet where you have to make the data ready, I told you that you have to have one file of training which consists of the training as well as the validation data. Okay. So here you can set the percentage of validation. So if it is, say, I write it as 15, it means that 15% of my data from the training will go for validation. Okay, so this facility is available over here. You can give this. Okay, if you don't want validation, you can give it as 0, but then the question of overfitting also will be there. It will persist. However, cross validation also can be done, that we will see a little bit later. Okay. And the threshold. Okay, so you can change this also. Now let's say okay. Okay, so the initial parameters have already been fixed. Okay, and I'm saying okay, my input data, my data has already gone inside. Okay, the 9 input parameters, 1 output parameter, and I'm using this for training. Obviously you all know that we have to do the training first. Okay? Now let us go to more options first. Okay, and here you want to see the output model. Okay, and if you want to see the training splits and the evaluation measure, entropy inversion measures, you can see that, but this is not required over here. And the output predictions you want to see. Okay, if you say null, then you won't be able to see the output predictions. Okay, but if you say that in plain text, you can see it here. You can choose CSV also. Okay, you can do that. Okay? Yeah, and you'll check that and say okay. Now once this is done, our basic implementation, everything is ready. Now just say start. Okay. Now once you do this, okay, your neural network has already worked. Okay, and it has given you the answer as well. Now please beware, we are working with training data set. But what is important is to analyze what this particular thing is saying. Okay. So first of all, let us see the error measures. You people are aware about the error measures. Okay. Now just check out the correlation coefficient here is 0.8097. Okay. Now this particular data which I have chosen, that's a deterministic type of data, and so 0.809 is it can perform much better. Okay. Now why this particular thing is less, the correlation coefficient, followed by the other error measures like mean absolute error, root mean square error, relative absolute error. Okay. Now why it is less? Because the number of hidden neurons which we have seen, they are only 2, and that's the reason, that is one of the reason why it is very less. Okay. We can increase that and see. I'll show you some other thing also after this, but let us first analyze this data. Okay, now let us go ahead. We are more interested in this particular part, that the training data, this is the actual data, that is 29.6, 50, 28.98. Okay. And this is the predicted data. Predicted data, that is the output, that is what is given by your model. Okay, and of course this is the error. Okay, so this particular table is important for us, and this particular table gives you this error measures. We can calculate this error measure. So WEKA is actually doing this for you directly. Okay. Now, how to save this? You can just, I'll tell you this also. You can just select this. Okay. Everything, put it in notepad. Okay. Select it notepad and open that notepad in Excel. Okay. You will get this in Excel format. Okay. It is as simple as that. Now let us see this particular part, the most important one. Okay. So you have used WEKA classifiers, function, multi-layer perceptron. Okay, with all these data, learning rate, momentum rate. Okay, epochs are where only 500. Okay, and so on and so forth. So these N9 LWC dash TRN, that was my file name. That is a training data set. How many instances I had? 179. That is how much amount of data I had? 179. Okay, and there are 10 attributes. That is the 10 parameters which we popularly call as. Out of which 9 are my input parameters. Okay, and S, that is the 10th parameter, is my output. Okay. Now, just see this particular part. Okay. Now, what is this? Now, in this particular WEKA, this threshold is popularly, I mean, it's nothing but the bias. Okay. It's in WEKA for bias, they call it as threshold. Okay. So, threshold is nothing but bias here. So, now just check out here how this particular thing is. I'll show it to you in PowerPoint. Just give me a minute. I'll show you how this data sheet should be read. Okay. Now somebody will have to help me with this. Okay. That I'll not draw the whole thing, but I'll show you some few points over here. Okay. Now, how was your network, the architecture? It was 9. So 1, 2, 3, 4 to 9. Okay. And this was C, NFA, RFA, and so on and so forth. Okay. Then in between, the one hidden layer with 2 hidden neurons. And of course, these all will be connected. Okay. And you have an output S. Okay. Now, how to check with this data? I'll show it to you. Okay. Now, just check out here. This is threshold. Okay. Threshold is nothing but bias, as I said. So, this bias is how much? 0.6595. So just help me with this if I forget. Now that's a single bias. So this particular reading or this particular data is from this particular factor. So this here, this bias will be 0.656, whatever it is further. Okay. So this bias is for this particular layer. Okay. And this connections are given in this way. This is popularly called here as node 1 and node 2. Okay. So from here to here and from here to here, what is the data? Let us see. See here. It's given here node 1. It is minus 1.466. Okay. So this will be minus 1.466 and this is minus 1.1315. Node 2 minus 1.1315. So it is minus 1.1315. I hope this is very clear to you. Okay. You have to read it in this way. Now the second part is, now there were 2 nodes. That is 2 hidden neurons. So for each of these inputs, okay, the corresponding weight is given over here. Now there are 2 hidden neurons. So you'll have 2 bias. I mean a single bias which is divided into 2 nodes. So you can see here the threshold for the first node and threshold for the second node. Okay. So let's put this also on the sheet. So let us see here. This threshold is minus 0.315 and 1.9078. Somebody please help me with this number as well. 1.907 minus 0.3151. So this will be, for this, the bias will be minus 1.31 something, whatever it is. And for here, the bias will be, काय होता number? 1.9078. So it is 1.9078. Okay, so that is how the thresholds will be marked. Now what you have to mark? You have to mark the connection between each input parameter and each of the node. So the connection will be like this. Okay, I'll draw it for node 1 first. Okay, so it will be in this way and the further things. Okay, so one by one we can mark it over here. So just check out here. Now this is sigmoid node 1. I'll talk about this. This is a limitation. I'll talk about it. Node 1. So attribute C, you have the weight which is given. So what is the weight? 0.2072. So this is 0.2072. What is from NFA to node 1? NFA, node 1, NFA is minus 1.180. So it is minus 1.180. Okay. One more we will put for RFA 0.094. So it's 0.094. So now this is, and it continues. Okay. This is with reference to the input parameters and the first node. Okay. As you can clearly see it, it's written here node 1. Okay. And similarly, it will be for the node 2 as well. So you will have, I'll use a different color over here. Okay. So here you can see here, this is your node 2. Okay. And you can read this data. Now for node 2, for attribute C, what is the weight? 0.033. So let us mark here. So this is 0.033 and so on and so forth. Okay. That's how the weights are being shown in this particular WEKA. I hope this is clear to you. Okay. Now purposely I did not show directly in the matrix. I wanted to show you this so that the interpretation becomes easy. Okay. You can write this in matrix form, of course. Okay. So this is how you have to read this particular data. Okay. And of course, I spoke about the time taken to build the models, 0.05 second, because there is only 2 hidden neurons and a single layer. Predictions on training set, and this is the error measures. Okay. Now, one more thing is, what is this sigmoid? Now, this is what is one of the limitation of WEKA, is that in both the layers, now in this condition, okay, the architecture is 3:2:1. 9:2:1. Okay. In both these layers, the transfer function which will be used will be sigmoidal. Okay. Now you cannot change that. That's the inbuilt thing. We cannot change the transfer function. That is the limitation of WEKA. If you want to change, then you'll have to code it in Java, and then you can do that. However, in the inbuilt system, it's only sigmoidal, and that's the reason here it's sigmoid node 1, node 2, etc. Okay. So now this is about the training. Okay. So training पे तो ये 0.8 आ गया, ठीक है. Now let us check out with what happens with the testing. Okay. Please also make sure that validation is already done over here. Okay. We have already given 15%. Okay. So now for the test set, what we will do is, now you can see over here, there is supplied test set. So I'll just click over here, go to set. Okay. And now I have to open the file which contains the testing file. Okay. Which we have already made it into, which we have already saved it separately in the CSV format itself. Okay. So check with this again, the test file, as you can see here. Okay. Say open. Now, how can you verify that it is done? When you can see that the class is, if you click it here, drop down box, you can see your parameters. Okay. So once this is done, it means that your test file is going inside properly. just say close. Okay. Now once this is done, now you don't have to change anything because the weights and biases are already fixed. Now you just have to check it on the testing data set and just say start. Now once you do that, now just if you check these weights, they are going to remain the same. It's obvious because this is a testing data set. Okay, the weights and biases are already fixed during the training phase itself. Okay, and this is your actual and the prediction. Now this is for testing. Okay, and these are the error measures for testing. So you can see the correlation coefficient is 0.7668. Of course it is less. Okay, followed with other error measures. Okay, so this is how you have to work in.
Can I disturb you? Can I disturb you for a minute?
Okay, sir. Yeah, sure.
Yeah, maybe I'm not very sure. But here, if you see on the left-hand side, in your training, we have done the cross-validation, 10-fold cross-validation.
I'll talk about it.
And the percentage split over there is say 66.
Yes.
That means remaining 33% data is almost used or made it separate. So from say 100 data, only 66 data is getting trained and remaining 33 is getting here or separating out here for 10-fold cross validation.
Yes.
And then again we are giving remaining value for testing. That may be one of the reason also that we are getting bit less result, because actually our data is very small.
Yes.
So if we don't give cross validation at all, maybe results may improve, but we are not sure about the overfitting.
Correct, sir.
These are very complicated things of neural network. But just I thought in my mind that if this cross validation 10, if we make the percentage split maybe 90%, that means out of 100 only 10 values every time the different train values are validated. That means for that validation is there. Maybe this can work better. I don't know.
But sure. We'll have to try it out. Yeah. Thank you so much, sir. In fact, this was my next part which I was going to talk, but you already spoke, so it is good for me. So thank you so much. So of course, students, as sir rightly said, you can try out with these as well. So the percentage split and the cross validation as well. Okay. Now this is the procedure. Now I'll show you something else. Okay. If you people remember, I'll go to training data set again. Now for easiness, what I will do is I'll close this and I'll start it fresh. Okay. Now you would say that every time do we have to do it afresh if I change the hidden neurons or anything? Then the answer to that is no. You don't have to start afresh every time. Okay. But for easiness in understanding right now, I am just doing it. Okay. So you can continue this. Okay. Say for example, again, I take training data set and I change it over here something. Okay, say I'll make it 5 and this is coming in between. Okay, and I change this. Okay, still I can continue. Okay, so you can see the result sheet over here. Okay, left hand side bottom. Okay, so every time I can see that, but here right now when I'm telling you about this may create a confusion, so I'll start afresh. Okay, so I'll show you the GUI as well. That's very interesting part. Okay, again I'll load the data. Just give me a minute. I don't know if this thing is disturbing me in between. Okay, I'll load my data here. So again, I'm loading my training data, similar to the previous one, nothing different. Okay. Now again, I'll go to choose. I'll go to functions. I'll go to multi-layer perceptron. Okay. And I'll click on training data set. Okay. Use training set. If you want, you can keep cross validation also. Okay. And as sir rightly said, yes, you can try out with this also. See what the results are. Okay. Generally, the cross validation, the folds, maximum number of folds are 10. Well, it's a thumb rule because whatever literature we have seen, they never go beyond 10. Okay, so till 10 it is enough. Right now, I'll keep it as training set, and I'll again click it on this particular tab. And now what I'll do is I'll keep this GUI, I'll make it true. Okay, GUI is nothing but graphical user interface, so that I can see my network. Okay, now hidden layers, now we have taken 2. Let me increase that a little bit and say I'll make it 8. Okay, and learning rate and all you can change it later. Right now I'll keep it, and I'll keep the training time, that is epochs 500 itself, and let me keep the validation as say 15% for time being. Okay, and let me say okay. Now once I do this, now when I start, now this is something which will appear. Okay, now this is actually a network. I think you can read this network very easily. Okay, so 9 input, this is an architecture, 9 as to 8 as to 1. So 9 input parameters, 8 hidden neurons with a single hidden layer in the single hidden layer, and your output neuron. Okay, now you can see here at the bottom of the page, the epoch right now is 0. The number of epochs is 500, which we had given it by default. If you want, you can change it here. Okay, here itself you can make the changes. Okay, then learning rate and momentum rate, right hand side, right hand side bottom, you can see that. You can change it here also. Okay, and just say start. Okay, that's the answer. Okay, you'll get this. Now see here, you had 8 hidden neurons. Okay, so you can see over here, as I showed it over here as well. So you have 8 nodes. Okay, and each of these node with reference to output will have these weights with the output. Okay, and of course each node and each of the input parameter reading in the second similar way. Now here I did not check this part, output predictions in plain text, and so it did not show me the actual and the predicted. If I check that, I can see that as well. Okay, so I'll get this, and I'll get the actual and the prediction as well. Okay, so this is what you can do with this WEKA. Now one more thing I'll show you. Okay, if I say use cross validation, okay, and instead of temp for time being, let me say the cross validation folds are 2. Okay, and I will say start. Now once I do this, okay, now I'll have to run this, thrice. The reason being, first time it will be full training, the second time and the third time will be the cross validation, which will be done. And that's the reason I'll have to run this 3 times. If you say start, okay, it will start. I'll have to accept it. Okay, so first time I accepted it. Next, I'll say start. It will give me the answer. Okay, there's something wrong here because I accepted it. 1 second. Sorry. I'll start it. Yeah. So this will be start first time. Okay, if I accept this, it will directly get accepted without going ahead. So it will directly be only the training. Okay, once I do it again, okay, now this is the first fold which will happen. Okay, because I clicked it second time, and the third fold. So directly after the third one, it will give me the answer. If this is say 5, okay, then I'll have to do the start. I'll have to run the start thing for 6 times. 1 will be the training, and the remaining will be the cross validation. That is the folds. Okay.
May I again interrupt you, please?
Yes, ma'am. Yes, sir.
What exactly happening over here is, suppose there are 100 values, and you are saying that you are having the folding 2 times. Okay. Your cross validation is 2-fold cross validation.
Yes.
Then it is doing twice. If you say it is 5, then it will do 5 times.
Yes.
See, what it is doing is, it is having some data already split.
Yes.
Okay, for validation. Out of 100, let us say it is keeping some 15-20 values apart. Now, which 15-20 values apart? For the first trial which you did, it is say 1 to 85, and then on remaining 15, it is doing the validation. Then in the second case, it may be, say 15, 16 to 100 is
Huh.
training, and first 1 to
Yes.
15.
Hmm. Hello? Hello? Am I there? हॅलो गोरे मॅडम ऐकू येत आहे सर यू आर इनऑडिबल हाँ ओमकार कैन यू हियर मी ओमकार yes you can hear me okay so I'll just continue from here what sir was saying was if you have two fold you know then the whole training data set will be divided into two parts out of which one will be randomly taken it for validation. Okay, so that's how it is will work for the cross validation. Okay, so we'll just wait for sir to come. Just a second. We will join back. Okay, so that's how cross validation system will work. Okay, now in between, if you say you did say the first cross validation. Okay, sir is back. Yes, sir.
Yeah.
Huh.
So that is what I just wanted to say, that
Mm-hmm.
we were always having this issue, that how the cross validation is done, what is this 10-fold, 2-fold, and all these kind of thing. So that is what it is. They are actually doing it in WEKA very easily.
Yes.
Maybe in Python it would be easy, but in MATLAB it is not that easy to do
Yeah.
the. Nowadays it is easy with our new coding style. There we can give for the validation, but this folded cross validation, random value chosen for doing the cross validation, is actually a very good aspect of WEKA. Though there are certain other
Yes.
limitations, this is
Limitation.
actually a plus point. This is a
Hmm.
plus point of WEKA. And you can
Yes.
also try with clicking that percentage split instead
Huh,
of
yes.
66%.
Hmm.
That means, if I understand it, it is actually doing here that thing also. That means inside the training data,
It
it
is
itself is doing that again. That means
it is
if you
splitting.
give the full data set, and if you
Hmm.
give 70-30, then here it
Hmm.
itself will do the training. This is what
Yes.
I am thinking about right
Yes,
now.
yes, sir. You
Then
said
we
it
may not use
rightly.
the supply.
Hmm.
Uh,
Hmm. You
So
said
then,
it rightly,
whenever
sir.
new data set comes, no,
Hmm.
whenever new data set comes, then we can just supply it as a test data set.
Yes, sir.
What I'm saying is, suppose we are having say 150 values, whatever you are having today, then I will not try anything separate as a test set. I would put all the, I will put them all in training set. Then I would say the percentage split is 70-30. Here instead of 66, I would say 70. So from 150, 70% of that, 105 values I think would be used for training, and remaining would be directly used for testing.
Yes, sir.
And then if suppose after a few days you get some more data, then you can save this model, right? You can save the model in WEKA. Then you can reload this model and apply the supplied test set. You do not require to run this network again. Directly it can give you the answers. I think that is what is the purpose.
Yes, sir. You said it
That's what I
correctly,
see.
rightly, sir.
Maybe I am wrong, but
No, no,
see,
no, sir. You are very much
everybody
correct,
has to
sir.
try this way. There is no other
Hmm.
way out to understand things.
Yes, sir. What you said is perfectly correct. Just I'll add one more thing here. As sir rightly said, you can save the model, which you can use it later. Okay. So how to do that is you can go to this result list, right click for options, go here, right click, and you can see load the model and save the result. So you can do that as well. Okay? So that you can use it at the later stage. Okay? So uh, so that's what is neural network in WEKA. So you can now change here if you want hidden neurons, hidden layers. If you want, you can change and you can check with the GUI how it works. Okay, you can change these parameters and you can validate it. Okay, and see where you will get the maximum performance. So yeah, so that's it from our side for demo. of neural network in WEKA. So, and this GUI of course is there. You can also do it manually. You can click over here if you want to build it yourself. You can click over here a hidden neuron. Okay, and this is selected, and if you want to have connections, then you can click on the other one. You can do this manually also. But if you really ask me, whatever I have worked with WEKA, don't do it manually. It's better easy to do it through tab, because then if it's a very big network, this may create a little confusion. So personally, I don't prefer this. However, you can try it out, not an issue at all. Okay. One more thing I would like to tell here is that in fact, if you are having say five-fold or two-fold cross validation, if you are using, okay, I'll just minimize this, and say you started this, and after two-fold itself you felt that okay, that much is okay for me, I don't want to go for five-fold. Okay, cross validation, then you can accept this answer at any particular moment. Once you accept it, it will stop there, and that particular answer will be accepted. Okay, that also can be done. Okay?